All right, so real quick review. We're going to go over addition of vectors. So review of addition of vectors. And so let's say we have two vectors. We've got A and we've got B. Okay, and so if we're just start with A plus B. Okay, well then using the tip to tail method, A plus B is going to wind up with this being A plus B. All right, but then we also have, because addition and subtraction are the same thing with vectors. So if you are subtracting two vectors, you're really just adding a negative. So if we were going to do, say, A minus B, this is the same thing as A plus a negative B. Okay, that's how there's still addition. And so a negative B is really just the other direction, right? So that would be, so that would be, so that would be negative B. All right, and so A plus a negative B is going to be, here's A, and the negative B is in the other direction. And so we're going to have so that's going to be A minus B. And A minus B is actually going to be is similar to well, we know that we know that subtraction is really the opposite of addition. And so if we do we can also swing it around and we do B minus A. Well, this is going to be the same thing as negative A minus B, right? So we can take this A minus B, okay, or this is also B plus a negative A. So these are all the same. So B is, we're going to start with, I'm not drawing a good B. There's B, okay, and then we add a negative A. Well, negative A is that vector, and so negative A, B, and so we wind up with that, which is B minus A. But if you look at A minus B, it's just the opposite direction, and we know that negative. Okay, so that's a review of our addition of vectors. All right, so we're going to apply this now. We're going to apply this to the concept of relative velocities and moving objects. So, okay, so we're going to all right, so we have relative velocities. And so we're going to start with, so imagine we have a plane that is traveling at 160. All right, so let's see if we can draw a plane here. All right, we'll kind of plane, we do here's our plane, and our plane is traveling at 160 meters per second east. All right, but it encounters a crosswind that is traveling at 120 meters per second south. Okay, what is the final velocity of what is the actual velocity of the plane? Because planes don't travel. If it's 160 meters per second east, it's only traveling that through the air. That is its airspeed. Okay, it travels through the air at 160 meters per second, but it's not traveling over the ground. And so what is its velocity relative to the ground if we're traveling 160 meters per second east? Well, this is where we add these vectors together, and we draw both of them. So this is its airspeed, which is 160 meters per second in that direction. But then we also have the air that is pushing him at the same time, and that's going to be 120 meters per second south. So his actual velocity with respect to the ground, because you go from place to place, right, for airplanes, and so you have to calculate these two vectors when you're trying to go from one place to another. And if we're going from one place to another, then his actual velocity is going to look as a vector like that. Well, this should be pretty simple because this is just a right triangle, right? If it's due south for the wind and it's due east for the airplane velocity, and so this is going to be, can you guys see it? I picked those numbers in particular. Okay, this velocity is going to be 200 meters per second in that direction. That's a 3, 4, 5 right triangle, right? Okay, so we add these two vectors together, and that would be our relative velocity considering the plane, the airplane, and the airspeed, right? So that's if we have an airplane. Now, there's another situation. I'm going to give you another. This one's a little tougher. Okay, this time let's say we're in a boat. All right, I'm on a boat. I'm on a boat. Take a good look at me. I'm on a boat. All right, so we have a boat, and we're trying to go from point A to point B, and this is a straight line. It is directly across the river. The river has the river flows, and the river has a motion to it itself of 4 meters per second. Now your boat, has a velocity equal to 5 meters per second. Okay, so how fast, or in what direction do we need to travel? Or more to the point, in what direction do we need to point the boat? Yuck. In what direction do we need to point the boat to point the boat to cross the river? And land and dock at B. Okay, so this is the tricky part. Well, what we have is we want this vector right here, okay, to be our resultant. Okay, but we know, so that's x. Okay, but we know that we have the river flowing in that direction, okay, at 4 meters per second, and we have our boat traveling across, okay, at 5 meters per second. So we need to point the boat so that we're going to have a horizontal component to our velocity, right? And so this boat is going to have this component for the velocity, and it's going to have to compensate for the 4 meters per second in that direction, because we don't want to flow down the river. We want to just go straight across. So we need to we need to steer the boat at an angle that compensates for the 4 meters per second downriver and still gets us across, and so that's going to be the horizontal. So we're really looking for this angle this angle theta right here? Well, if we know that we travel at 5 meters per second, and the river is traveling at 4 meters per second, then we can find this angle right here to get us across. And that this theta, okay, well, that's the opposite leg, and this is the hypotenuse leg. And so opposite and hypotenuse is sine. So this sine theta is going to equal 4 meters per second over 5 meters per second, which equals 0.8. Okay. And this winds up being this is our 53 degrees. Okay, well, you guys can plug that into your calculator. But that's the basis for relative velocity and riverboat problems. And they get a little further into it. We can find out how, like, where up the, well, we just did that one. How fast we have to go if we are trying to go straight across. If we have an angle, how fast we have to go if we're trying to go straight across, that sort of thing. So that's it for tonight's lesson, and we'll see you guys on Friday.